Okay, welcome back, guys. So these are the notes that I have for just the actual 3B on scientific notation. So I kind of introduced it in the other video, and now we're going to look at it with a bit more rigor. And as I mentioned, we're also going to look at doing arithmetic with numbers that are expressed in scientific notation. Alright, so let's look here. It says converting to scientific notation. So when you're going from an ordinary number to a number expressed in scientific notation, you're going to move the decimal point to come after the first non-zero digit. So like in this example here, the decimal point is understood to be at the very end, so I would have to move it such that it's behind the 3, okay? So we end up with 3.042. Because remember, we want this first number here to be between 1 and 10. And then it says for the power of 10, use the number of places the decimal point moves. The power is positive if the decimal point moves to the left, and negative if it moves to the right. So see, if I move it to the left, actually let me zoom in a little bit. Come down here. So since I'm moving it to the left, when I think about it like this. When I'm moving it to the left, guys, I'm making my number smaller. So 3042 is becoming 3.042, which means I need my power of 10 to be bigger. So that indicates to me that I want this to be a positive 3, okay? So it becomes 3.042 times 10 to the third power. 10 to the third power is the same as 1,000. Alright, and then this one here, I would actually need to move the decimal to the right. I'd need to move it such that it's behind the 1, so that becomes 1.2. And when you move the decimal to the right, you're making the number bigger. So to offset that, you need your exponent, or your power of 10, to make this a smaller. Okay, so this is 10 to the negative 4th. Alright, so that's how to go from ordinary notation to scientific notation. So what about in reverse? If we're going from scientific notation to ordinary notation, well, you just go in the opposite direction, basically, guys. So it says the power of 10 indicates how many places to move the decimal point. Move it to the right if the power of 10 is positive. Because if the power of 10 is positive, that means you want to make the number bigger. And you make it bigger by moving it to the right. So see, this 3.6 right here, if I move it to the right 6 places, I'd have to fill in all those places with zeros, and now I would have 3,600,000. And then you would move it to the left if the exponent is negative. Okay, so this power of 10, negative 3, that means you'd want to make 5.7 smaller. So to make it smaller, you move it to the left 3 places, and it would become 0.0057. Okay, so you're really just going in reverse. All right. Okay, so now we're going to look at how can we... Okay, so we just reviewed on how to convert from ordinary to scientific notation and from scientific notation to ordinary notation. Okay, and we really covered that in the previous video. Now we're actually going to look at doing some arithmetic with numbers that are expressed in scientific notation. And for multiplication and division, this is pretty straightforward. Okay, it says multiplying or dividing numbers expressed in scientific notation simply requires operating on the powers of 10 and the other parts of the numbers separately. So look at this example here. So this is my first number, okay? Remember, these numbers are expressed in scientific notation. So this is my first number times my second number, okay? So the way you do this is you work with the 6 and the 4. So you say 6 times 4, that's where you get 24. And then you work with the powers of 10. And this is where we went over working with those powers of 10 in a previous section. 10 to the second times 10 to the fifth is 10 to the seventh, because you have to remember you have to add exponents when you're multiplying exponential expressions. So you end up getting 24 times 10 to the seventh, okay? Now you're not finished, and the reason is because 24 is not a number between 1 and 10, okay? We need it between 1 and 10. So there's a little understood decimal behind the 4, so I need to move it to the left one place. Now it becomes 2.4 times, but since I moved that decimal to the left one place, I need to adjust my exponent by 1. I need to either bump it up 1 or move it down 1. And what determines that is what you did to this number. When you move this decimal to the left, you've made this number smaller. So to offset that decrease, you need to increase this exponent. So it becomes 10 to the 8th, okay? So in this section, guys, when you're working with multiplying or dividing these numbers expressed in scientific notation, at the very end, you may have to adjust a little bit, such that this first number here is between 1 and 10. So you may also have to adjust that power of 10. But anyway, this would be your answer. 2.4 times 10 to the 8th power. Now, with division, it's very similar. So if I scroll on down here and we look at this example, I've got this number in the numerator expressed in scientific notation. Now this is a smaller number, and I know that because this is a negative power of 10. And we're dividing it by another small number. And so the way you do this is you just divide these two pieces, and then you divide your powers of 10. So 4.2 divided by 8.4, you could plug that into your calculator and you're going to get 0.5. And then you've got to remember that when you are dividing powers of 10, you subtract the exponents, okay? So when you multiply powers of 10, you add the exponents. When you divide powers of 10, you're subtracting the exponents. So what they've done here is negative 2 minus negative 5. Remember, these two negatives would turn into a positive. So this would be like positive 5 with negative 2, which is a positive 3. And then again, at the very end, we need to make an adjustment, because this number right here is not between 1 and 10. It's less than 1. So to account for that, I'd move my decimal to the left 1, and it would just become 5. Or I said to the left, I meant to the right. But when I've moved it to the right, what I've essentially done is made the 0.5 a larger number. Now it's 5, which means I need to make my exponent smaller to account for this increase in value right here. I need to decrease my exponent by 1. So this will become 10 to the second, okay? And this is your answer, 5 times 10 to the second. Okay. All right. So let's do a couple examples of our own, and then we'll look at some addition and subtraction, and then a couple word problems. Okay, so it says do the following operations without a calculator. Express answers in scientific notation. Well, here we are multiplying these two numbers expressed in scientific notation. So this means we're going to multiply the 3.2 times the 2, and then we'll multiply the 2 powers of 10, the 10 to the 5th times the 10 to the 4th, okay? Well, you can do this by hand on paper. 3.2 times 2 is 6.4. And then my powers of 10, since I'm multiplying them, I need to add my exponents. So 5 plus 4 is 9. So this is going to give me 10 to the 9th power, okay? And just to double check, make sure this number is between 1 and 10, and it is. Okay, so we're good. This is our answer. Now for part B, we're dividing, okay? So I'm going to set this up as a division problem. 9 times 10 to the 13th divided by 3 times 10 to the 10th. Well, what we've got to do here is divide 9 by 3 and then divide our 2 powers of 10. Okay. So 9 divided by 3 is 3, and then 10 to the 13th divided by 10 to the 10th, you subtract exponents. 13 minus 10 is 3, so we get 10 to the 3rd. And again, double check to make sure this number is between 1 and 10, which it is, and we're good. This is the same as 3 times 1,000, which is 3,000. A power of 10, if you have a power of 10 and an exponent, the exponent just tells you the number of zeros you have. Okay. I think I may actually stop here, guys. I'm trying to make these videos a little bit shorter so they're easier to watch. So I think we will cover how to add and subtract numbers written in scientific notation and look at a couple word problems in the part 2 video. Okay. All right, so I'll see you then.